What's up, guys? Welcome back to another episode of IB Computer Science, and today we're gonna talk about B2.4. And B2.4 is all about programming algorithm, but due to time constraint, today we're only gonna talk about part one, which is linear search, binary search, bubble sort, and selection sort. And corresponding to the linear search and binary search is corresponding to B2.4.2, this subtopic in the IB Computer Science book, and bubble sort and selection sort is corresponding to B2.4.3 in the IB Computer Science book. So yeah, hopefully in the end of the video you guys will know clearly about what is linear search, binary search, bubble sort, selection sort, what are like the difference between those, and what is the purpose of using either search or sort. So let's just directly start with linear search and binary search. Linear search is sometimes also called sequential search, and we use this, notice the word search. We use the search thing when we want to find something in a data set. So let's say we have a array. Let's say array is actually just like a list of numbers. So let's say we have an array, and the value in the array is 0, 1, 2, 3, 4, 5, and 6. And if we trying to find 4 in this array, then we will use a search method to find where is 4 in this array. Okay, so let's just jump straight into how does linear search and binary search work. So linear search, how it's work is it will go through the array from left to right one by one and check is the number in the array that it's checking the thing we're trying to find. So sequential search or like linear search, it's let's say for example in this array, what we're trying to find is 4. What a sequential search will do is it will do something like this. First of all, is 0 4? No, 0 is not 4, and 4 is like as if 4 is the thing we're finding. So it will go, is 0 4? No. Is 1 4? No. Is 2 4? No. Is 3 4? No. Is 4 4? Yes. Then now we find the key. Key is what we are trying to find. So 4 is the key. So linear or like sequential search is pretty intuitive. By the way, guys, linear search and sequential is the same thing. Just like some people prefer to read it as like sequential search. Some people prefer to read it as linear search, but two are the exact same thing. It's just based on like personal preference on how to read it. So yeah, this is linear search. It's pretty intuitive. Okay, let's go with binary search. So binary search is kind of more complicated because it has like way more step. But you guys can know like can think of like the overall concept is it will like kind of separate the array or like the data set into two part, and then eliminate half a part, then eliminate half a part and find the target number we're trying to find, which is like the key in the other half that didn't got eliminated. So here, first of all, it will do a preliminary step. What is a preliminary step? So like it's the step before the actual action that it's gonna do. So first of all, it will make the array list in order of size. So if let's say for example, this array list is like say 1 and 6. So let's say this is the original array. The preliminary step will switch 1 and 6. Make it in the order by like size. So after you do the preliminary step, it will then set a variable to store the lower bound index. And guys, just remember here when we talk about like either lower bound, upper bound, we're always talking about the location of the array. We're not talking about like the value inside the array. We're talking about the location. And a list of array always start with location 0. So the first number in the array is always in like zero, array 0, and the second number will be array 1, the third number will be array 2, uh third number will be array 6, and like something like this. So let's say today if we have 1, 2, 3, 1, this 1 will be in array 0, and this 2 will be in array 1, and this 3 will be in array 2. So array always start with 0. This is something you guys have to remember. So let's go back. After we set a lower bound index, which mostly in the first step is like the first step, the lower bound index will always be 0, and as we go through like 6 or like 7, the lower bound index you'll probably like come up to other places. So after setting the lower bound index, we'll set a upper bound index. Upper bound index is also the location in the array. And then after setting the upper and lower bound, we'll calculate the middle index using lower plus upper divided by 2. So guys, this one is also a location. This one is also a location in the array. This is not a value. These are all not value in array. These are all location. So after finding the middle of the array, we will then compare the value in the middle index to what we trying to find, which is let's say like let's just use the word key to represent the thing we're trying to find, the number we're trying to find. So we will compare the value in the middle index to check whether it is the key or not. And if the middle index is a key, then yay, congrats, binary search is done. We found what we found our what we're trying to find. But the hard part is if the value in the middle is not the key, then we'll have to go through more steps. First of all, we gotta check, is the value in the middle position smaller or bigger than the key? Because you guys remember like when we talk about the preliminary step, we talk about that this one have to, like the array have to be ordered by its size. So the purpose of checking like bigger or smaller, what we're trying to do is we're trying to eliminate the side that is bigger or smaller so that we can search our key in the more smaller data sets. So if value in the middle position is smaller than the key, then we can disregard or like don't care and like take it out the left side of the array, because as the array is in order of size, if the left is middle is smaller than the key, then everything in the left of the value would also be smaller than the key. And how do you disregard? So now we set a new lower bound variable to middle index, like the new lower bound variable will become middle index, the previous middle index plus 1. Let's say equal sign here. So for example, if we want to find if our key if we want to find 4, just and then a, yeah, okay, so if we want to find 4 and now the mid index is 3, so we know that 3 is smaller than 4. So in this case we will neglect everything in the left side of 3, and so everything in the left side, like this one, we will neglect everything here, and the new lower bound will be 3 plus 1, which is 4, because we checked 3, which because 3 is the middle index, so we check it first. We here in like step, what's it called, step 5, oh wait, no, yeah, step 4, we check whether the middle index is the key we're trying to find. So in this case we're also gonna take 3 out. So the new lower the new lower bound would be this, where the value 4 is located, and the upper bound will still be where the value 6 is located. And don't worry guys, like if the value we're trying to find is in the left bound or right bound, the whole process right here, it will just like continue to repeat again because we only check the middle. We never check the left bound or the right bound. So this whole thing, like the whole binary search, it only ends when the middle value is the value we're trying to find, or it will just continue repeat it until like the whole array or the whole array runs out. Okay. And if value in the middle position is bigger than the key, then we can disregard the right side of the array because as the array like is in order size, um, as the array is in like order size, if the if the right side if the right side uh if the right side of middle is bigger than the key, then everything in the right of the value would also be bigger than the key. And how to disregard, so like it's similar, really similar to here, it's basically the same thing, and but now we set a new upper bound. Notice here we said we're setting a new lower bound, and here we're setting a new upper bound because it's bigger. So let's say for example we have this is our array. Oh wait, I haven't finished. So we set a new upper bound variable to the previous middle minus 1. So let's just give an example. So like for example, we have, this is our array list. If we want to find 2 and the middle index is now 3, this is what thing we're trying to find. Let's highlight it. And this is the middle index. Knowing that like knowing that 3 is bigger than 2, so we already know that anything in the right side of 3 will always be bigger than 2, and it will never be 2. So here what we're trying to do, we're trying to eliminate the right side of 3 and also 3 because we already checked whether 3 is a key or not, and it is not. So then we neglect everything in the right side of 3, and the new upper bound will be 3 minus 1, which is 2. So the left array will only be these 3. So the lower bound will be the 0 and the upper bound will be 2. And like I said guys, we in this binary search, we never checked the lower bound or the upper bound. So we only find our key when the middle value is the key. So here are some pros and cons of both sequential search and binary search. So sequential search is good for small data sets and it's super intuitive. But it's also like really bad for large data set. And for binary search, it's really efficient for a large data set because like every time we're basically eliminating half of the data sets. But its cons is it have to go through preconditioning order by size, by magnitude, and this kind of take a lot of like time. It takes some time and some energy, so it's not that good, and it's also really unnecessary. Like binary search is unnecessary for a large data set, and the logarithm is more complex. And guys, I attached the code of Python and Java for both binary search and sequential search right here. And because like explaining the code will take kind of long time, and there are also like two kind of code, so like it's kind of two different syntax. So you guys can just check out this Google Doc and under the video, and check the code yourself. Alright, after talking about search, we'll talk about sort. So bubble sort and selection sort. And sort is, we use sort when we wanna make the dataset comes in order. So remember, in here we talk about a binary search. We have a preliminary step, which is make the array list in order of size. That is the time where we have to use sort. So there are two. So today we're going to talk about two kind of sort, which one is bubble sort and another is selection sort. So what is bubble sort? Bubble sort is basically you compare adjacent data and switch adjacent data. Only two data, not three. So like, if this is the array, we're looking at these two, then these two, then these two. We're looking two at a time. And yeah, and we switch it based on the magnitude, based on the size of it. So like mostly like in most cases, the smaller value of the thing will be in left, and bigger the bigger the value, it will be in right. Um, so here it sort through whole array. So like uh whenever we're doing bubble sort, it's going through the whole array. So it's mostly like in most cases it's having multiple swap per pass, and one pass is like, you can understand it as like going through the array one time. So it will go through the array until there's nothing to swap, and the array will end. And here are the code for bubble sort, which I also attached both Java and Python code. And you guys, like as I said, like this one, if I explain the code, it would take way too long. And also the code is in different syntax, and I'm only familiar with one syntax. So like one high level language code. So I'm probably not gonna be able to explain the other part that comprehensively. So yeah, you guys can check it out yourself. And here's another approach for bubble sort. Okay, so selection sort is comparatively easy compared to like bubble sort, because what it's doing is basically it's going through the whole data set one by one and find the smallest in the array, find the smallest value in the array and put it in the front of the array, then continue this process until the whole array is bit sorted. So it goes through the whole array, find the smallest value, put it in front, then goes through the array second time, then find the second smallest value and put it right next to the smallest value until everything is done. So here is a visualization, a visual image of how what's it called, selection sort works. So let's say here's an array. We go through once. Oh, 2 is the smallest. We move 2 to the front. And we go to the second time. Oh, 3 is the smallest. 3 is the second smallest right now. Then we move 3 into the front. Then we go through 7. Oh, 7 is smallest. The third smallest. We move 7. Then ls 9. No, oh, 9 is the smallest. So like we doesn't change. Then we go to the last time, checking everything is in order. And here are the code of Java and Python for selection sort. Oh, and here is a very good YouTube short video of bubble sort and selection sort. I found it online, and I really want to show you guys. So here is bubble sort. You guys see like it's like kind of like switching between adjacent data set, and this one is selection sort. You guys see like this one is like getting the smallest one and putting in front, then getting smallest one putting in front, getting second smallest, so the second smallest one putting in front, and go through this process, continue. So bubble sort is more ideal for like a larger data set, while selection sort is more ideal for a smaller data set. And also like selection sort, I think, me personally, I think selection sort is its whole logic is like kind of more intuitive compared to like bubble sort. So yeah. Alright, I also attached the video link here. Wait, let me close it. I also attached the video link here in the bottom of everything here in B2.4.3. Guys, like you guys can like access the node. This one is shared with anyone with a link. So like if you guys need, it's my node is just under my video here. I can show you guys. Charles. node is just right here, and you guys can just like click it and access the node. Alright, thank you guys. See you guys next time.